Hello, hello, hello. Today we're going to be talking about biconditionals and definitions. So we're going to be talking about how to write biconditionals and recognize good definitions. Today it should be short and sweet. First thing you have to know what a biconditional statement is. It's a single true statement that is true for both conditional and converse. And we would write it with an if and only if in the middle between the two, hypothesis and conclusion. A good definition can be written as a biconditional statement. So let's test this out. So here's my conditional statement, and I want to find my P and Q because I want to first write it as a converse. So my P would be if two angles have equal measure. My Q would be then the angles are congruent. That's a true statement. So I'm going to write the converse, which is if two angles are congruent, then they have equal measure. That is also true, since both the conditional and the converse are true, then I can write it as a biconditional statement. You want to look back at your conditional statement to write that. So I could say two angles have equal measure if and only if the angles are congruent. So again, two angles have equal measure if and only if they are congruent. Now here I already have the biconditional statement because it says if and only if. I want to figure out what the P and Q are, and I want to write a conditional and converse statements. So the first part should always be the hypothesis. So when I'm writing my P, it would be a ray is an angle bisector. And then my Q would be after the if and only if. It divides an angle into two congruent angles. As you can see, I'm shortening up the words. If you understand that, you should also shorten the words. You should pause this right now and try writing your conditional and converse statement. So the conditional statement would be, if a ray is an angle bisector, then it divides an angle into two congruent angles. And the converse would be, if a ray divides an angle into two congruent angles, then it is an angle bisector. What is a good definition? A good definition uses terms, and these are commonly understood terms. It is very precise and avoids words as large, sort of, almost, and could be reversible. That means you can write a good definition as a biconditional statement. So for this problem, I have a definition is a quadrilateral is a polygon with four sides. You should look for the two parts within the definition. Here I have quadrilateral is a polygon, and it has four sides. So that would be my two parts. You should try to pause this and write this as a conditional statement. My conditional statement says if a quad, which is a quadrilateral, is a polygon, then it has four sides. So now you should pause and try to write the converse. And that looks like if a quad has four sides, then it is a polygon. As you notice, for both of the conditional and converse, I started with if a quad, so if a quadrilateral. That's not part of the P's and Q's. The P was polygon and four sides. So that's what I change around. When you write your sentences, they still have to make sense. So now try writing that biconditional statement. So the biconditional statement could say something like, a quadrilateral is a polygon if and only if it has four sides. Since both conditional and converse were true, you can write the biconditional statement. Now it says, which of the following is a good definition? Remember, good definition has to be precise and only can mean that thing. So a fish is an animal that swims. That's not a good definition. A dolphin swims, and it's not a fish. Rectangles have four corners. That also isn't a good definition because I could draw four corners and it not be a rectangle. That's not a rectangle, but it has four corners. Giraffes are animals with long necks. Also not a good definition. An ostrich has a long neck, and it's not a giraffe. A penny is a coin worth 1 cent. This would be the good definition because it's the only thing that it could represent. I could also write that as 1 cent coin is a penny. That's true both ways written. So if you want to make sure it has a good definition, see if you can find any counter examples. If you can, then it is not a good definition. And that is all, folks. See you next time.